All right, I think we're ready to get going. So thanks everyone for coming on out. And in our session, let me hit the button here so we can get going. All right, so this is the VMware Cloud Foundation Deep Dive. And my name's Kyle Gleed, and with me is George Elliston, right?
That's right.
So I'm with VMware, he's with Omega Phi, and we're going to kind of tag team this presentation. So standard disclaimer, we are going to be talking primarily about VMware Cloud Foundation 2.2, which just GA'd last week. So last Thursday, I think, was the official GA. This is the latest shipping version, so we'll be talking about it. There will be some areas where we will talk about some of the futures and some of the things that are kind of coming. Just keep in mind that the disclaimer does apply. So in terms of introduction, so I've been at VMware for about 7 years. I started out, my first 4 years, I was over the vSphere world. Worked primarily with vSphere through versions 5.0, 5.1, 5.5, and then about 3 years ago I moved over to this role where I'm now part of the integrated systems business unit focused on software-defined data center and integrating the different components together to help enable this vision of our, making the SDDC kind of mainstream. And with that, I'll let George kind of introduce himself.
I'm George Elliston. I'm the network administrator for Omega Phi. Located in Columbus, Georgia. We do financial services for fraternities and sororities across the U.S. I'm kind of responsible for all of the networking and data center operations at Omega Phi.
All right, great. So here's our agenda. So we're going to talk about Cloud Foundation. I'm going to start with an overview. I'm going to try and keep the overview light because I feel like there's a lot of presentations, a lot of presenting on Cloud Foundation, and you're going to have a lot of opportunity to see the overview. And then we're going to get into the architecture and talk about the architecture, talk a little about deploying Cloud Foundation, workload domains, and then we'll get into some deploying considerations. So real quick here, is anybody by chance in the audience running Cloud Foundation today? So we got one person, a couple people. Anybody running VxRack SDDC, which is basically Cloud Foundation shipped by Dell EMCs? Okay, so we got a few of you. All right, that's good. So let's go ahead and jump in. So the best way to think of VMware Cloud Foundation is when it comes to deploying a software-defined data center, there's a number of building blocks that you have that is going to come together. So there's the vSphere components, there's the vSAN, there's the NSX, and you got to bring these components together in a way that is going to enable and create the software-defined data center. And you can definitely build that in a do-it-yourself fashion. I could start by inserting an ISO into a server and deploying a PSC, and then deploying another one, and then deploying a vCenter server, going into a web client, defining my data center cluster, and I can do all those steps. I can kind of piecemeal. That's definitely a way to do it. That's the way we've typically approached things in the past. But with Cloud Foundation, we're really kind of trying to move away from that kind of build it yourself and really kind of get to this more of a mode where we deploy Cloud Foundation through automation, and instead of spending our time building the software-defined data center, we spend and focus our time on consuming the software-defined data center. So less time kind of in the garage building it, more time actually logging on and using it. And so as we go through the presentation, just kind of keep that aspect of the goal here is to simplify the software-defined data center. So with that, here's the core building blocks. So I like to always kind of talk about Cloud Foundation. It's new, but at the same time, it's not new. And what I mean by that is, if you look at the building blocks that make up VMware Cloud Foundation, these are not new. It's the compute virtualization with VMware vSphere. It's the storage virtualization with VMware vSAN. It's the network virtualization with NSX. And those are technologies that have been around for several years, and the industry kind of leading technologies. And we're bringing those together. So in that regard, we're not really doing anything new. What is new is that bottom piece, that lifecycle automation. What's new is we make it easy for you to deploy, to stand this up, to operate and maintain, to include patching and upgrading. So the automation aspect is really the new component. And I want to stress that this is really this is not just a packaging exercise. This is not just us taking those core building blocks and bringing them together and putting them out as a package that's easy to consume. This is an engineered solution. This is a VMware validated design. And what I mean by validated design means that we implement this, we test it, we validate it, we put it through its paces, and as new updates come, we put those updates in and we retest and we revalidate. and it's an ongoing process. So as you go forward with Cloud Foundation and your software-defined data center, if a new version of vSphere comes out or a new version of NSX comes out, it's continually revalidated, and those updates will become available to you as they are validated. So it's an engineered solution. It's not just a packaging exercise. The automation makes it very easy to deploy and operate. It comes with the full NSX stack to include all the security capabilities. And it also is very easy to run Cloud Foundation, not just on infrastructure that you own and manage in your data center, but also as a service through public cloud providers. So everybody's probably heard of the VMware Cloud on AWS. We have VMware Cloud Foundation service on IBM, and we also have announced this year at VMworld offerings of VMware Cloud Foundation on Rackspace and CenturyLink and other cloud providers as well. And so the idea is you have this common foundation across both my private cloud and my public cloud, and then that enables a hybrid cloud, because now as I want to deploy workloads, I can use vRealize Automation, or I can use vSphere Integrated OpenStack. I can use that common management platform to deploy in both places, and I'm deploying on the same infrastructure. And if I want to move workloads from one place to the other, I can do that without having to convert VM formats. If I have a workload running on-prem and I move it to the cloud, it's the same underlying stack, so if I have a security policy, that security policy can go with it. So I can reduce some of that risk associated with moving to the cloud. I can ensure security. I don't have to worry about moving a workload from a private cloud to a public cloud and having performance change because I went from, say, one type of storage to an NFS storage or something else. It's all vSAN under the covers. And because it's based on VMware, it's based on our product stack, of course, it's an ideal environment for running both those traditional applications, those traditional workloads, as well as those new, emerging, evolving cloud-native workloads. So the key here is that we do have a standardized architecture. When we talk about the architecture, this is a HCI-based solution. So vSAN is part of the design. NSX is part of the design. A common question I will get asked is, hey, can I buy Cloud Foundation but not buy vSAN? Or can I buy Cloud Foundation and not buy NSX? And the answer is no. It is an integrated solution. All those components are there. They're all required. They're all used. And they're all deeply integrated. And again, it's an engineered solution where we engineer the entire stack together, and then we provide through the automation the make it very easy to deploy, stand up, and use. And the way we do this is through the SDDC Manager, and we're going to talk about the SDDC Manager. Now, that note there about automates day 0 to day 2. So I want to take a minute and just kind of explain what that means, because I get a lot of questions. So we are literally talking about taking physical hardware that's racked up in a server that has no identity. We start with 2 top-of-rack switches, a management switch, and as few as 4 vSAN ready nodes. And we can scale this up to 8 racks with up to 32 servers per rack, so it can scale up to 256 nodes today with Cloud Foundation 2.2. And we can introduce some inter-rack switches to cover that. But the idea is when you start out that first rack, those servers are in a pixie boot mode. They have no identity. I mean, the switches. The switches are in a pixie boot mode with no identity. The servers are just bare metal. There's no identity. The way we install the software and put the software on there is through the automation. We use SDDC Manager to push that software out, and then we use SDDC Manager to carve out that capacity into a management cluster that we call a management domain to deploy the PSCs. So we are talking about, when we talk about day 0, we are talking literally about instantiating the software on top of the hardware. Once we've done that, we get into how do I allocate this capacity out for workloads? And we have this concept of workload domains, and we can go out and create workload domains. And so that is a key part. So that's the day 0, day 1. And then once you've deployed those workloads, we've got to do patching and upgrading. So that lifecycle management, the ongoing patching, the ongoing upgrading is also built into the SDDC Manager. So when we talk about automating day 0 to day 2, we are literally talking about everything from the standing up and imaging and installing ESXi to the ongoing patching and updating later on. Fully automated through the SDDC Manager. So now we're going to get into a little bit more. That's kind of the marketing overview. Like I said, I'm going to try and keep that short. Now we're going to jump into a little bit more detail on the architecture. So we've talked about the building blocks several times. Those are the core building blocks. So we are taking compute, storage, and network and bringing those together with the automation, the SDDC Manager. And that's what makes up Cloud Foundation. And so the SDC Manager, again, is that the automation component, and it's going to do everything from the initial deployment, configuration, policy-based provisioning, all the way up to include the patching and upgrading. It is a very prescriptive architecture, so this poster is available to everybody. If you want to go out, I'll have a link at the end. You can go out and download it, and each one of those boxes is kind of a drill into each area. So we go over a breakdown of how we lay out the physical network, how we lay out the logical network, how we lay out the storage, and it's a very prescriptive architecture. The benefit of having a prescriptive architecture is it's repeatable. So we're kind of, a couple years ago, there was this notion of snowflakes. And how everybody who was deploying it a slightly different way. So we're all the same. We're all running the software, and we're all trying to implement this software-defined data center, but everybody was a little bit different and unique. And that creates problems when you want to scale this out and you want to have it really make this go mainstream. So in order to address that, we come in with a very prescriptive design, and then we automate the deployment of that. So there are some trade-offs in terms of that prescriptive design. So there will be some examples where you'll look at this and say, why did you do it this way, or could I do it this way? And that's one of the trade-offs of having something that's fully automated is you have to make some sacrifices in terms of flexibility. But it is that prescriptive design, and it is fully automated. And the components there that we deploy, so we deploy the full VMware stack, and then we also have integration with the vRealize Suite and Horizon. So as part of Cloud Foundation, I can deploy what we call a VDI workload domain, which will deploy the Horizon stack on top of Cloud Foundation. And that includes basically going in, saying I want this, and when I'm done, actually having desktops that I connect to. So the integration with the Horizon. We also deploy Log Insight, and we in the old version, we deployed vRealize Operations. Right now, vRealize Operations is kind of one of those, it's out in terms of the automation. It will be coming back in very soon. I'll talk a little bit more about that as we go forward. So we do have a bill of materials, a software bill of materials, and this is showing you the versions of software that we run. So we are now running vSphere 6.5 Update 1 with vSAN 6.6.1, NSX 6.3.3, the SDC Manager, Log Insight, and Horizon. You'll notice the two columns there, the deployment column and the patch and upgrade. So the deployment column is highlighting which components we do automate the deployment and configuration, and then the patch and upgrade shows which components we do the automated patching. So you'll notice that it's not a one-for-one, so we do have some components that we are not yet doing the automated patching and upgrading. That's something that we hope to add in the future versions, but we do the automated deployment. In addition to, so this is, as the note says, this software that we see here is what you get when you download the Cloud Foundation software bundle. The software bundle for 2.2, I think, is right around 16 gig in size. So it's a very large download. It's an ISO file. And the reason why it's so large is because we have all these components. And then in addition, we have integration with the other components of the vRealize Suite and that you can actually manually deploy and manually upgrade. We are working to try and pull in these other components so that hopefully at a future point in time, the deployment and patching columns for all those products will say automated. So it's a work in progress in terms of bringing some of these other components in. Okay, again, we have a prescriptive architecture that we install on top of hardware, and we have a specific type of hardware or a subset of hardware that is qualified for Cloud Foundation. So earlier I mentioned how we start with a physical rack and how we own the switch configuration. We own the ESXi deployment. And in order to do that in an automated way, we have to basically know about the hardware. We have to know the hardware make, the model. We use APIs to do a lot of this. We use out-of-band discovery. In order for that to work, we got to make sure the hardware is qualified and certified for Cloud Foundation. So we do have a VMware compatibility guide where you can go and you can basically search based on version and identify what are the qualified switches, what are the qualified servers, what are the qualified server configurations. Now on this slide, I've intentionally not called out individual vendors because it's one of those things that's constantly changing. And if I put the vendors on this slide and then you download this 3 months from now, it would be out of date. So what I've done here is I've not called out the specific vendors as much as go to that compatibility guide and check for any updates. But what I will tell you is right now for server support, ready node support, we support Dell, HP, Lenovo, QCT, Fujitsu, and I very likely could be forgetting one or two. On switches, we support Arista and Cisco, and on management switches, we support Cumulus. And again, that's kind of what we support today. There will be others getting announced, and so check that compatibility guide for the latest versions. We do support both all flash as well as hybrid ready node configurations. And again, you can support based on the different versions. But the kind of the underscoring point here is that if you have existing hardware in your data center, an existing environment, and you want to deploy Cloud Foundation on it, you'll need to make sure that that hardware is qualified with Cloud Foundation. All right, so now we're going to drill into compute virtualization, and then we're going to go over each of these in a little bit more detail. And what I'm going to do is I'm going to talk specifically about each component, how it's architected, how it's implemented. But before I do, I was supposed to let George chime in a little bit, and I skipped over. So I just want him to kind of share with you, from a customer's perspective, his experience with using Cloud Foundation, and primarily around deploying, and his thoughts around, you know, what they were faced with deploying and how the automation has helped them. So George, why don't you go ahead and take a few minutes and just kind of share with us?
Sure, thanks. So about a year and a half ago, I was tasked with coming up with a model that was easily scalable. Our company was going down the mergers and acquisitions road, and I was here about a year ago, and when Cloud Foundation was first announced, and it came back, and we were looking at all of those pieces. We wanted to have NSX and didn't want to have to manage the Cisco switches and all of these other things. And earlier this year in January, I racked and stacked 10 Dell servers. VMware came in. The whole process was basically all plug and play. There's an appliance that goes in and images all of these things, deploys all of it, and then you get this environment that's stood up with SDDC Manager. And you can go in there and basically set up your workload domains and kind of set, hey, I need this many servers in this workload domain. I want to use it for this, and it goes and just does it. And one of the cool things we were really interested in was the update and the patch management. I didn't want to have to worry about going and upgrading NSX and vSAN and all of these other parts and pieces. SDDC gave me that. I go in, select which workload domain I need to update, and it goes and does it. Takes each host one at a time, goes and patches those.
All right, great. So yeah, so again, leveraging that power of automation in order to make the SDDC simple. So now, since this is an architecture deep dive, let's jump into the architecture and get into detail. So we are built on top of vSphere. That vSAN ready node is our building block, our primary building block, and on top of that we're going to run vSphere. We're currently running vSphere 6.5 Update 1. So if you're going to deploy vSphere, what are some common questions you need to ask yourself in terms of architecture? Am I going to go with the appliance? Am I going to go with an embedded PSC, an external PSC? How many PSCs? What is that architecture? And again, we have a very prescriptive architecture, and we're going to deploy in a very prescriptive way. So let's talk about how we're doing that today in Cloud Foundation. So what you see here in the top is this management workload domain. So I'm going to talk about workload domains in a little bit more detail, but every time you hear me say workload domain, think vSphere cluster. We're just talking about this is a management cluster. And this management workload domain is stood up and configured for us automatically by the SDDC Manager. The SDDC Manager is going to start by deploying a pair of platform services controllers, which is going to instantiate my SSO domain. So you see those two there. These are not set up in a high availability pair. They're set up as kind of peers. So I have those two, and that's going to help with scalability. So if I have, if I deploy, each time I deploy a workload domain, I get a new vCenter server, it's going to register with the PSC, and it'll do that in a round-robin fashion. So the first workload domain will register with the first PSC, the second one will register with the second PSC, the third one will go back to the first one, and we'll kind of stagger that as we scale up. But that represents our SSO domain, and all our vCenters will be registered against that SSO domain, which means that within Cloud Foundation, all my workload domains will be configured in enhanced link mode, which means I will have a single pane of glass across my infrastructure. Okay, Along with that, we also have vRealize operations and log insight deployed inside the managed workload domain, and that is going to provide our centralized log aggregation as well as our centralized monitoring. Now, you'll notice that when in the picture below where I have the different workload domains, you'll notice that the PSCs and the vRealize operations log insight are installed at that management layer. So I'm not getting a separate instance of log insight for each workload domain. I'm having a single log insight for my Cloud Foundation environment that's aggregating logs for all my workload domains. The same with operations. And then once I have that, I go out and I deploy my vCenter servers and my NSX managers. Each workload domain, to include the management workload domain, gets its own vCenter server and its own NSX manager. Now you'll notice here as the slide points out, in the top box, that represents what runs inside that management workload domain, and you'll notice that the vCenter server and the NSX manager runs in the management workload domain. So we are separating the management components from the clusters that they manage. So when I create a workload domain, the vCenter server, the NSX manager is going to run inside the management workload domain, and they're going to manage a vSphere cluster that's sitting outside. So we're kind of following best practices there in terms of that separation. What that also means is for each workload domain, I can have separate availability policies, I can have separate storage policies. When I define it, I can determine whether or not I'm going to do redundancy, no redundancy. I'm going to determine how my objects are going to be striped in terms of vSAN. That's all defined at the vCenter level. So across workload domains, I could have workload domains for test dev, workload domains for production, running side by side, each managed by their own vCenter server, each managed with a separate set of availability, performance, and storage policies. And so that's how we deploy and architect the vSphere. So it's kind of a high-level overview, but you'll see this is the way it's going to be deployed for us. So the highlights here, vCenter and NSX managers run inside the management workload domain. All vCenters run in enhanced link mode. So we can have up to 15 workload domains. Okay, now the reason why we can support the 15 workload domains is because the vCenter has a configuration maximum that says they support, as of 6.5 update 1, 15 vCenters in link mode. So with Cloud Foundation, another thing that's important to keep in mind is we are not changing, or we are not able to break any of the vSphere maximums. If there's a vSphere maximum out there, because this is vSphere, we honor that maximum. So if you say you want more workload domains, well, when vSphere raises their limit, we'll raise our limit, type thing. So we are inheriting those. And then we have that centralized log monitoring and log aggregation. And that's the vSphere overview. Now in terms of the storage, software-defined storage, and the way the storage is laid out, it's pretty straightforward. How many people are using vSAN? Good. So that's a good number. And if you're using vSAN and you know anything about vSAN, one of the things you know is it's pretty easy. I go in, I have my flash, my server with the local storage, my flash, my hard disk, or my all flash. And to go in and actually create a vSAN data store is a couple of clicks. And so there's really not much to it in terms of Cloud Foundation. Really what we do here is we do auto-claim the disk on the server, and we will automatically create those disk groups and create that vSAN data store. This is done at the time we create or we define the workload domain. And we have the ability to create workload domains and expand workload domains and delete workload domains. So what that means is if I start out with a 4-node workload domain and I grow and I want to add more capacity, I can add a 5th node or a 6th node. And when I do that, SDC Manager is going to automatically go out, create disk groups on that node, bring those disk groups in, and expand that vSAN data store. So it's pretty much what you would expect. The ready node requirements and the storage requirements, this is just an example. Don't look at this and say, whoa, what about this or what is it? Again, go to that compatibility guide and see where we're at in terms of sizing and support for different configurations. Similar to the comment I made before about the vSphere maximums, the vSAN design and sizing guide, we don't break any of those rules. We don't override any of those rules. So you go to your vSAN design and sizing guide, and what they say you can do with those nodes is what we will do within Cloud Foundation. The big key here is we have that support for both hybrid and all-flash. And again, I'll just kind of underscore, this is an ACI-based solution. So can I install NFS and mount NFS with Cloud Foundation? Yes. But can I deploy Cloud Foundation without vSAN? No. vSAN is an integral part. And so this is just kind of an example showing that where we have the different options, the hybrid as well as the all-flash. In my experience, the all-flash seems to be the more popular option. So since we are 6.5 update 1, that means that at your disposal, you're going to have dedupe, you're going to have encryption, you're going to have compression. All those latest features available with vSAN 6.6.1 are going to be available to you. And I'll just kind of take a moment here, and because one of the common things that comes up is, since this is an HCI-based solution and it is vSAN, what do we do for things like data at rest? So I'm going to create backups. I need a place to store the backups. I'm going to have templates. I'm going to create a content library, and I want to store those templates. I don't necessarily want to use my all-flash storage for that. So you can mount up IP-based storage, and you can use that storage as well. So we do support NFS, and you can mount that up inside the workload domains, in addition to vSAN. So we do support the external storage. It's just that we don't support an option without the vSAN. And George, I believe you guys in your configuration, you have, how do you set up that
So yeah, we had the same thoughts. We did not want all of our backups in vSAN. So we actually deployed an external NAS device to hold all of those backups and some of those things.
All right. So good. So yeah, so look, that's showing some of the flexibility there. Okay, so now we'll move on to the networking. Now, this is one area where we're a little bit unique, I think, from a traditional VMware approach to the way we approach the data center, because when it comes to Cloud Foundation, with regard to the top-of-rack switches, the management switch, and the inter-rack switches for the Cloud Foundation environment, we own that. The SDDC manager owns that. So here's an example of what that would look like. So within each rack, we're going to have 2 top-of-rack switches and a management switch. And when you go to a multi-rack configuration, you're going to have those rack interconnect switches. Again, those switch configurations for those switches are deployed, managed, and configured through the SDDC manager. And then in the first rack, we're going to have an uplink up to the data center network. So for your network guys out there that have your existing network, when you bring in Cloud Foundation, what you're going to need is you're going to need to plug in Cloud Foundation to one of your routers on your network, one of your leaf routers, one of your routers out there on the edge of your network. But within Cloud Foundation, that's going to be a bubble the SDDC manager is going to own and configure. Okay, and so let me see what. Okay, so and what we implement here is it kind of mimics a leaf and spine network, but it's not a true leaf and spine network. So if when I say leaf and spine, don't take me too literal in the sense that what we're doing here is, because we have the 2 top-of-rack switches in each rack, and we go to a second rack, there's 2 top-of-rack switches. The interconnect between those is 40 gigabit. And then each host has 2 10 gigabit NICs to plug into each top-of-rack switch. And so what that gives us is a very high-speed east-west transport, so that as we scale out the environment, that pipe scales out very well. And as you need to route in and out, you would send the traffic up to the top-of-rack switches and route them out for that first rack. It is a stretched layer 2 design today. And so kind of getting into that idea of a prescriptive design, we don't yet have within Cloud Foundation support for layer 3, routed layer 3. Today it is a stretched layer 2. Again, that's something we're looking at possibly in the future. And then once you uplink to your data center, that uplink can be either layer 2 or layer 3, and you can configure that based on your requirements. And so that's the physical network, and like I say, it's a little bit unique because when it comes to Cloud Foundation, there is this piece of the physical network that we're going to own and we're going to manage through SDDC Manager. So let's hold questions till we get to the end, just because we want to make sure we have time to get through. So we do own and configure that. We do own and configure and manage this physical infrastructure, and on top of this physical infrastructure, we're now going to create workload domains of vSphere clusters, and inside each cluster there is going to be a virtual distributed switch. And that virtual distributed switch is going to have a number of port groups. There is an out-of-band port group that's going to connect all the nodes on a private network. So within a rack environment, VCF environment, all the nodes are going to have this private 192, 168, 100 network where I can talk. So from a management perspective, in terms of an administrator who wants to access consoles and troubleshoot stuff, there's that kind of private network they all share. So that's important when you think of it from a multi-tenancy perspective, potentially. But then in addition to that out-of-band network, we have our management network, we have our corporate network, external access, then we have our vSAN, vMotion, and VXLAN. And that is the virtual distributed switch. And then on top of the virtual distributed switch, we install NSX. So as part of the automation, we are installing the NSX manager, we're configuring the NSX controllers, deploying and configuring NSX controllers, and then we'll go out and we'll create a transport zone, and I believe we install a logic switch. Now, one thing right now with Cloud Foundation 2.2, we do, when you deploy VDI workload domains, when we get into deploying the virtual desktops, we do have some automation around the NSX edge services gateways we deploy. But out of the box, your workload domain would have just your servers, your VDS, and you would then go in and configure the NSX, the distributed firewall, distributed logical router, any edge services gateways based on your requirements. So I believe you are deploying some NSX edges, right?
Yes.
So maybe let us know how you're doing that.
So yes, my environment's very multi-tenant. All of these other companies that we've acquired need to be separated. And we're doing that logically separated with the NSX edges, so I can manage all traffic in and out of all of those environments, and manage those rules and all that good stuff.
Okay. So, show of hands, who's looking at NSX, working with NSX today? Okay, so that's good. All right, so that's kind of the storage configuration. So the things we want to call out here is, you'll notice when I look at the NSX configuration, this is showing a virtual infrastructure workload domain. Again, I emphasize that the NSX manager, along with that vCenter server, is going to run outside the workload domain in the management domain. The NSX controllers will run inside the workload domain. And then you'll have that full set of NSX capabilities available to you. So you can deploy. This is using the Edge Services Gateway, but I could just as well draw a line down there on the ESXi servers and talk about distributed firewall and things like that. And so with this kind of topology we have, it's very easy to migrate workloads between workload domains, just simply vMotion them back and forth. And if you go in and you enable things like distributed firewalling and stuff, of course you get all those benefits where as that workload moves around, those policies will follow with it. Okay, so we talked about the architecture from a vSphere kind of architecture. How are we deploying PSCs, how we instantiate an SSO. We talked about the storage, we talked about the networking. So now let's get into the workload domain. So as I mentioned, every time I say workload domain, think vSphere cluster. And within Cloud Foundation, the way we allocate capacity is through the concept of a workload domain. So we typically have, three types of workload domains right now. So there's the management workload domain, which is created for us during bring up. You cannot delete the management workload domain, but you can expand it, you can grow it. And then in addition to that, we have a virtual infrastructure workload domain, or a VI workload domain, which is basically just a vSphere cluster. It's a pool of capacity on which you can deploy your VMs as you see fit. And then we have the virtual desktop infrastructure workload domain, which is basically a virtual infrastructure workload domain with Horizon 7.2 deployed on top of that, and the necessary components deployed to include desktops. So we have that full stack. We have the ability to create, expand, and delete. Again, the management workload domain is an exception. We cannot delete the management workload domain, but you can create workload domains, you can expand workload domains, and then we can have up to 10 workloads. Actually, that should be 15 workload domains running in parallel. And that needs to be updated because the vSphere team just updated their link mode maximums up recently, and I didn't update this slide. A couple of notes here. So for people who are running Cloud Foundation or who have maybe looked at Cloud Foundation in the past, one of the challenges we had with the earlier versions of Cloud Foundation is, as I start out with one rack and I deploy my management workload domain, it's a minimum of 4 nodes. Okay, so the first 4 nodes in that first rack is going to instantiate my management workload domain. Now, why 4 nodes? This is running vSAN. vSAN requires 3. So the reason we require 4 is because we don't want to deploy something like Cloud Foundation and have this infrastructure, then the minute the node fails or goes into maintenance, put you in a degraded state. So we have 4 nodes. That way you have 4 nodes, you have the redundancy, and you can basically put hosting in and out of maintenance mode. So for the management workload domain, it's 4 nodes. And as you expand out and you add additional racks, we used to require that you would allocate servers in the additional rack into the management workload domain. So there was kind of a tax in the sense when as you expand out to the number of racks, the size of the management workload domain would grow and you would add additional nodes. With Cloud Foundation 2.2, one of the improvements we've made is that's no longer the case. That one management workload domain, those 4 nodes, are now all the management overhead you had. So as I scale out to my second and third and fourth rack, I do not have a requirement to add additional capacity. So that's a good change we have in this latest version. So if you're familiar with that, that's stuff I know a lot of customers have been waiting for us. So here's an example of what that managed workload domain looks like. So again, those 4 nodes at the bottom. This is created for us during bring up. So remember, with Cloud Foundation, at no point are we installing an ISO and installing individual components. Are we installing ESXi? That's all automated for us. There's 1 per instance, and again, that 1 per instance, and there's no need to expand or allocate capacity to that as we grow. Now, there may be use cases on why you would want to expand. If I have an 8 rack configuration, I may want to have 5 or 6 nodes as opposed to 4. But the point is we're no longer requiring that. And each workload domain has its own dedicated vCenter and NSX instance. In the coloring here, you'll notice the green components are kind of the required components, and then those blue components are optional. When we deploy the components, like for example, when we deploy Log Insight, we actually deploy it with redundancy in mind. So we deploy a 3-node Log Insight cluster with a master node, 2 worker nodes, with the embedded internal load balancer. So we do have a lot of intelligence in the way we deploy these components as well. And then when you deploy those individual workload domains, you'll see that in addition to for each workload domain that you deploy, there's additional VMs deployed inside the managed workload domain. So the point here is your managed workload domain is not static. When I deploy Cloud Foundation and I look at my managed workload domain and I take a snapshot, I come back a year from now, that's not going to be the same, because every time I create a workload domain, there's going to be additional workload put in that. So your managed workload domain will grow as the number of workloads domain grows, the number of VMs you put in there will grow, and so that is something you'll want to, you'll need to be aware of as well when it comes to sizing and anticipating the future growth. So you may want to leave a few nodes in that first rack kind of on reserve so that in the future, when it comes time to expand that, you have that capacity available to expand. Here's a virtual infrastructure workload domain. The highlights here is you'll notice it's in the big box there is a workload domain. The vCenter NSX manager are going to run outside of it, inside that manager workload domain. And then I'm going to have my own vSAN cluster, my own instance of NSX. And again, the NSX edge there is an optional component, but it's just showing your controllers and your VMs and what a virtual infrastructure workload domain would look like. And if we compare this to a virtual desktop infrastructure workload domain, you'll see it's pretty much the same. The big difference here is instead of VMs, I'm now running VDI, virtual desktops. And up there on the top, you'll see I now have those Horizon components that are running in that managed workload domain as well. All right. So George already alluded to the patching and upgrade, so I just want to take a minute and talk a little bit about how patching and upgrade works. So that slide I had earlier where we showed all the bill of materials and all the components and the components we do patching and upgrading. It's important to understand that we do have this bill of materials, and you will want to stay in alignment with the bill of materials. So one of the benefits of going with a validated design is that when you install a patch or an update, you know that VMware has installed that same patch and update, and a configuration looks just like yours, and so you can have very high confidence it's not going to break anything. So anybody here ever gets, like 3-4 years ago, get started with the Cloud Foundation, and you get everything up and running, and you install a vSphere update, it would update your vCenter, your PSC version, and then suddenly NSX Manager would break. That was a problem the customers had, and so part of what we're trying to address with Cloud Foundation with this automation is to eliminate that from happening. So as new updates become available, VMware we take those in the Integrated Systems Business Unit, we take those in-house, and we test and validate them against the architecture. And again, this is a standardized design, so it's the same architecture that you're running in your data centers, that you're running in the cloud. So there's a very high confidence that this is going to be successful, because if VMware did it and it worked, then it should work for me, because guess what? They're running the same software components, they're running the same versions, and the same configuration as I am. So when I apply this patch, I should be confident. And the way that the software updates will come available to you is by default, the SDDC manager is going to be looking for updates on the depot.vmware.com. Okay. Now, how many of you guys, if you deployed Cloud Foundation today, would want your SDDC manager talking directly to the public network? I don't see a lot of hands. So what you can do is you can stand up an internal kind of web server, and then you would update SDDC manager to look to that internal web server. So it'd be, my depot. .mycompany.com. And so you can stand that up, and then what you would do is as the updates become available, you would download those updates. Those updates will be available as software bundles. There will be 2 types of updates made available. There will be update bundles, which will be patches and fixes, and then there will be upgrade bundles. And so we'll download those, and you'll copy them up to the repository. SDDC Manager will see those pop in the repository, and it will automatically notify you through the UI that, hey, there's some updates available. You can then go in, you can view the details, you can read the metadata, you can see what's being updated, you can see if there's any dependencies, you can see if it's an NSX update, an ESXi update, an SDDC Manager update, and then you can choose when you want to download it. And when you download it, you'll download it to the SDDC Manager, and then you go in and schedule it. And when you schedule it, as George mentioned, you basically go in, you schedule it, and then it just goes and does its thing. You know, it's very much like VUM in the sense that it's going to go out and update the component. It's going to be transparent to the workload domains and the workloads running inside of them in the sense that it will take a host, put it in maintenance mode, reboot the host, put it back, and it will do the vMotioning of VMs. So there will be some overhead. So I'm not saying you'd want to do this during prime time. You still may want to do this during a maintenance window or schedule it during a weekend so that, because there will be some overhead with vMotioning and moving things around. But the idea here is we make it very easy. So one of the things we're very proud of internally at VMware within the Integrated Systems Business Unit is we have a number of customers that are running Cloud Foundation today. And if you ask them what versions they are running, so we came out with 2.0, and then we had a 2.1 release, a 2.1.1 release, a 1.2, 2.1.2, and a 2.1.3. So we've had in the last year several incremental updates to Cloud Foundation, and almost every one of our customers is running the latest version. So we're addressing that challenge where, how many of you guys are running a version of vSphere today that's more than 2 years old? A lot of people are running old versions of vSphere. I went to dinner last night with a friend who's running vSphere 5.5. And you don't run the old versions because you want to. You run them because I just haven't had time and it's risky and there's all this apprehension about doing it. So now if I can bring in through this automation to make it easy, it's going to be a lot better for us. Okay, so that's kind of an overview of the architecture, the components. So the next part, we're going to move into deployment considerations. And this is where we start getting into a little bit of the 2.2 aspects. So in terms of deployment considerations, there are two types of deployments. So this is one thing I want to caveat here. So people who are running VxRack SDDC, just be aware that while VMware Cloud Foundation and VxRack SDDC are largely the same thing, so basically what happens is Dell EMC takes the VMware Cloud Foundation and they have an offering they built around it they call VxRack SDDC. What I'm talking about here in terms of limitations are what we support from the VMware side in terms of VMware Cloud Foundation. They may not apply to the VxRack SDDC. For example, we have the consolidated architecture. So as we start out and we start deploying Cloud Foundation, our minimum entry point for getting started is 4 nodes. If you go VxRack SDDC, they're going to require 8 nodes. If you will have questions about that, come up after. We can talk about it. I can kind of explain why. But just be aware that if you're running VxRack SDDC, you want to kind of cross-check what you hear today with the Dell EMC folks to make sure that you got the right information. But we do support that starting out with 4 nodes, and that's our consolidated architecture. And essentially in this design, what you're going to do is you're going to have that management workload domain, which was stood up for us by the SDDC Manager. And you're going to run your infrastructure workloads on that cluster, and you're going to co-reside your workloads, your compute workloads, on that same cluster. And the way we do this is through resource pools. And SDDC Manager is going to create those resource pools for you. So this is a good design for smaller deployments where you're starting out small. And then the standard architecture is where you have a dedicated management cluster, management domain for your infrastructure, and then you deploy a separate cluster for your workloads. It's very easy to start with the 4-node, the consolidated design, and move into the standard design. So if I start with 4 nodes, and I start deploying workloads inside a resource pool on that management domain, and then I buy 4 more nodes, I bring them in, I can create my first workload domain, and now I can use vMotion to migrate those workloads, and I've just moved from my consolidated to my standard architecture. A very easy way. So it's a good way to kind of start with what you need and easily scale as you grow. So I got a couple of slides here, a little more detail. So again, when it comes to that consolidated architecture, it's that 4 nodes, and the key here is we're going to create resource pools, and we're going to leverage those resource pools. If you're familiar with the VMware validated designs, they announced just before VMware the VVD 4.1. And if you want more information on this, you can go to the booth, and we have people at the booth who can talk about this. They have the same notion. We're standardizing our terminology, so the consolidated architecture is something that's consistent across our validated designs. And again, the idea here is you would start with this for a small deployment of 4 nodes, and then the idea is as you grow your environment out, at some point, at some future point, you would go to the standard. So the standard is definitely the recommended architecture, and it's the architecture that everybody will eventually get to. But what we're trying to do is reduce that entry point so that if you want to come in with Cloud Foundation and you want to come in with a smaller investment up front, or you have a smaller use case that you know 4 nodes will support, you can get in and start it and with the SDC manager, start leveraging that automation, and then as you grow the environment out, you can move to that standard design, which we see here. So this is just basically showing how each, you separate your workloads based on workload domains or separate clusters. And that's the standard architecture. And so it's just kind of a summary comparing the two. And so with that, I think we've gone over a lot of the architecture. There's been a lot of information. So I want to now take some time and turn it over to George and just kind of let him share a little bit of his experience and how he's using Cloud Foundation. So George, I'll go ahead and let you just take the stage.
Yeah, so I think we may have hit most of some of these things, but kind of the environment as a whole is kind of got a whole lot of things in it. A whole bunch of different types of workloads and servers and environments. And I've been very happy with some of the things that I've gotten out of SDDC, specifically with kind of it does it all by itself when I need to manage it and add networks. I didn't have to worry about a switch config or adding VLANs and adding lags and all of that kind of stuff. That was great. So
in terms of your upgrade experience, maybe just share. So you started with what version?
We were on 2.1.
And then what are you running now?
So we are on the latest version of 2.1.3. That, like I said, that process is real seamless. You go in, you check it. One of the cool things, I was interested the first time that I started the update. I wanted to actually see what step. You can actually go in and watch what it's doing, which component it's upgrading, and where it is in that step.
Yeah, and that's a good point too, because something else, when you're deploying Cloud Foundation, and we talk about automating all these steps, the way it works is we take each individual step and we put it into we put them into a workflow. So we take each task and we combine them into a workflow. So as you're deploying things and as you're creating workload domains, you're doing patching, if you run into problems and that workflow fails, you can go into the SDC manager, you can see where it failed, you can fix that problem, you can resume the workflow. So there's a lot of resiliency built in as well.
And more recently, we actually did an expansion in the data center. That's kind of worth mentioning. We started with 10 nodes total. We added 6 this month. That process was very similar to the installation. Rack and stack, it goes and does the imaging, updating, and then you go through the expansion of the workload domain. And that process, I added 6 nodes in about a day, which was saved tremendous amount of time. If you were ever in the place where we were before, where you had a SAN here and a storage rack here, or compute rack, storage rack, and you've got to kind of mix all of those pieces together and all of that. That took a long time. In this model, it was easy as rack and stack, go through the imaging and expansion.
All right. So kind of just getting close to the end here, we'll open up for questions and answers in a minute, but just kind of summarize. So when you think of VMware Cloud Foundation, focus on that word foundation. And we are talking about building out a foundation for both the private cloud and public cloud. So while everything we've talked about today has primarily focused on the private cloud, if I went out to IBM Cloud and I deployed Cloud Foundation on IBM Cloud, everything we've talked about applies to that as well. So it's really a situation where I have infrastructure that I own, and I deploy the SDC stack on top of that, and I manage it. Now, when I'm ready to go to the cloud, whether it be IBM or AWS or any other cloud provider, I basically am treating that infrastructure just like my infrastructure. It's the same foundation across, and really enabling that hybrid cloud. And so with that, here's some links to where you can get some more information. And with that, we'll open up to questions. So they've asked if you got questions, if you come to the mic, or I can repeat them. And we'll just go ahead and take questions for the last few minutes here. Right here. Okay, so his question is basically saying we have a very prescriptive design. I said we have a vSAN ready node with two 10 gigabit NICs that wire up to the top of rack switches. What if I have a workload that has a need for a higher bandwidth? Maybe I would need additional NICs, or I want to go with 40 gigabit NICs. So right now the architecture is very prescriptive, so that would not be supported, the ability to go in and customize that. So instead what would happen is you can look for the VCG and see when 40 gig NICs get added to the VCG. So as additional capabilities come out, we will qualify the additional hardware and the different types of hardware, like Skylake Purely is coming, 40 gigabit NICs coming. So you look for those to be added and qualified, and then go that route. But to go in and say, hey, I'm going to pull these NICs out and replace them with 40 gigabit NICs, that would not be supported, and that would be a risk, because since we're going to go out and automatically discover and do out-of-band discovery, what if we can't talk to that NIC and we don't recognize it and we can't configure it like we need? Then it might prevent me from being able to install ESXi. So it is a prescriptive design. There are some trade-offs, but we're trying to be flexible in the sense that we recognize that we need to support multiple hardware types to have that flexibility. Okay, so question back here? Okay. Yeah, so the question basically is saying, hey, I'm running a hybrid cloud. My on-prem environment, I'm running, say, VCF 2.2, and in the public cloud, I'm running VCF maybe 2.5, and let's say they're running vSphere 6.5 update 2, and I'm running 6.5 update 1. So yes, that would be a challenge that you would need to manage, and that's where the automation, so what we're hoping is through the automation of the lifecycle management, automation of the packaging and upgrade, that you would not run in that situation for very long, because you would say, hey, you know what? The public cloud is running this, and keep in mind, this is where VMware Cloud on AWS is a little bit different than like on IBM. You control when you upgrade. So if you're going to upgrade to the next version, you may want to say, hey, well, I'm going to upgrade IBM Cloud to the next version, but wait, before I do this, let me check my on-prem version and maybe coordinate this so they're the same. VMware Cloud on AWS is slightly different because since it's a managed service, they'll update the backend for you. But we have the hybrid link mode, the hybrid cloud manager capabilities coming in, and as those mature and stuff, basically the same type of compatibility in terms of, you can run ESXi host in mixed mode, and you can run different versions. Those would all apply, but in general, as a best practice, you want to keep the two the same, and we're hoping that you'll be successful in doing that because we make it so easy for you to patch and update that there really won't be a reason to lag behind. So you'll say, hey, I got this issue, well, let's just go ahead and patch. Issue solved. Okay? Right. So the question is VxRack SDDC the same architecture? And the answer is yes, it's the same architecture. Where they are slightly different is the servers and the types of servers, the makes and model, and the manufacturers that they support will be a little, they'll obviously be Dell servers, Dell switches, and Cisco switches, I think. In addition, there will be some deviations. So like, for example, they have an additional server that they install on the rack where they run additional software components they use for patching BIOS and firmware that you wouldn't have in a non-VxRack. So there are some differences, and you can see where they're adding value and they may add additional components. But in terms of the architecture, rack, two top of rack switches, managed switch, and ready nodes, another rack, that's going to be consistent. And then obviously they'll be using their hardware. But at the same time, their hardware is going to be an option on the build approach as well. Okay, go right here. What does SDDC Manager run on? So the way it works, so this is kind of getting to the chicken and egg problem. Is that what you're kind of getting at? So let me kind of show you how this works. So I have a physical rack, and I have no identity on that rack. Okay, so we have an appliance called the VIA, and the way that works is you download the software. the OVA file, the software bundle, and an MD5 sum, which is basically the checksum file for that ISO of the software bundle. And you're going to have a Windows, a VM. You're going to have like either a MacBook Pro running Fusion, a Windows box running Workstation, or an ESXi. You're going to have a place where you're going to install that OVA. Okay, so you're going to go ahead and you're going to then connect that jump host to port 48 on the management switch. And keep in mind, right now we have no identity. These switches are just pixie booting, waiting for an identity. The ESXi host, there's no network connectivity. You know, they're wired up. The wiring's there, but we don't have a TCP stack running. So I'm going to go and deploy that OVA, and that's going to instantiate this VIA, this imaging appliance, where I'm going to upload that software bundle. Okay? So now I have a jump host that's connected to my physical rack, and I have this VIA running. So the way it works, and on these slides, you'll get these slides after the show, and the link there will take you to a YouTube video. But if you go to YouTube, you do a search on VMware Cloud Foundation playlist, you'll find all these videos on there. Those are the links. But what happens is we then take the VIA, and we go in and we tell the VIA the contents of the rack. I got 2 top rack switches, I got a manager switch, I got 4 nodes, I got 8 nodes, I got 12 nodes. However many nodes I got, what the make and model of those are. So we basically tell it what's inside the physical rack. And then it will go in and will instantiate a private network, 192.168.100 network, and it'll basically give me network connectivity. And the way it does is it starts up a DHCP server on that jump host that responds to those DHCP requests coming from the manager switch. It passes the manager switch's configuration. So the manager switch basically goes TFTP boot, gets its file, comes up, and now has a configuration. Now that we have that configuration on the manager switch, we have some plugins on that manager switch that allow us to do some out-of-band discovery to go to the top of rack switches and now pixie boot those. And then we can go out to the host and we can basically install ESXi on those. So we basically go out and now we have configured all the components. We have a TCP stack. We can now ping between them. And then what we do is we take the very bottom, node 0, and when I say bottom, we take one of the, we take the first node, and we configure a single node vSAN cluster. We copy the software bundle and we deploy the SDDC manager. So it's now running on that node 1. That's that first node. And then what you do is you go in and you connect to the SDDC manager, because now that it's been deployed and up and running, you connect to that. And now we're going to go through, we're going to synchronize the time, and we're going to ask a bunch of questions about the customer's environment. What's your DNS information? What subnets? What VLANs? What's the IP? What's the subnet and VLAN I used for your data center uplink? We're going to basically ask for this information, and then based on that information, we're going to go in and we're going to basically configure. We're going to re-IP the switches. We're going to configure the ports. We're going to re-IP the host, and we're going to configure those. We're going to go out and configure that uplink so that we have access outside. And then we're going to take that node where we've installed the SDDC manager. We're going to combine it with 3 more nodes, make that 4-node management cluster. And then we're going to deploy the SDDC stack. So that's kind of a quick overview on how we go from physical rack to up and running SDDC, and that chicken and egg problem was where does the SDDC manager come from, where does it get installed, and how do you use it to do the bring up? Yep.
So when you do provision like that, does it also provision the hardware mode access, the ILO, iDRAC, or is that something that you still have to have?
Right. So the question basically is, what about like the iDRAC, the ILO, and the BMC interfaces? And the answer is yes, we configure all of them. So, and this kind of gets into where we had the prescriptive HCL in terms of hardware compatibility list. Because in order for me, like if I have QCT in my lab, so the BMC ports I got to connect using admin and the password, and there's a certain way you connect to it. That might be slightly different for a Dell environment. But the SDDC manager has all that automation, and so when you tell it to make a model, it knows how to talk to it and how to configure it. But that's all included as part of the SDDC manager.
And those iDRAC settings in those MANET interfaces are actually listed for that particular host in SDDC manager. So it's listed as an IP that you can go and use that out of bound and get to.
One other comment. So what we just went through was how you would deploy it in your on-prem data center. If you're deploying this in the public cloud, it's the same basic process, but what ends up happening, you go to the cloud provider, so Rackspace, CenturyLink, or IBM, and they'll have their web portal that you're logged into, and you'll say, I want a cloud foundation service, I want it to be this big, and you'll provide those inputs. Then they go out, and there's an SDDC manager running that they talk to using APIs, and they're calling SDDC manager under the covers to deploy that infrastructure. So you don't access SDDC manager directly in the public cloud, is there under the covers being invoked through APIs through their portal. So it's a different look and feel, obviously, but it's the same basic process under the covers. You start with physical hardware. We're going to then go in, we're going to discover it, configure it, and deploy, create our management cluster, and then you'll basically connect to the vSphere web client and go to town. So, another question?
Today or tomorrow, can you provision workload domains without vCenter, like in a cluster and a centralized vCenter?
So the question is, can I create a workload domain without a vCenter server? And the answer is no. So today, so kind of getting into some of the limitations. So today, it's each workload domain has a dedicated vCenter, and it's a one-to-one relationship between a workload domain and the cluster. And so that means for each workload domain, you're going to have a separate NSX manager, a separate vCenter server, and one cluster. Going forward, we hopefully will see that. Well, we'll see that get relaxed, and you'll be able to have multiple clusters per vCenter. So you'll be able to go in and deploy multiple clusters and not have to have additional vCenters. One note about the vCenters: when you deploy Cloud Foundation, you buy Cloud Foundation, you buy vCenter, you buy SDDC Manager. That vCenter license that you buy covers all the workload domains. So every time you spin up a new workload domain, you're not getting charged for another vCenter server, because Cloud Foundation is going to cover all those vCenter servers for all your workload domains.
That was what I was asking.
Oh, yeah. So, and if you want to get started with Cloud Foundation and say you already have vSAN and vSphere, you can just buy the Cloud Foundation and the NSX, and you can bring your own licenses in as well. So if you already have, like, say, vSphere, vSAN, and NSX in your environment, and you want to get started with Cloud Foundation, you just have to go buy the Cloud Foundation piece. If you don't have any of it, you can just buy. So there's a lot of flexibility in terms of how the pricing and packaging works and get started. But the point being, you can even carry your on-prem licenses into the public cloud with you. So if you're on-prem, you got a bunch of licenses, you want to go public cloud and try that, and you can free up some of those licenses, you can carry those into the public cloud and leverage those as well. Details on how to do that I'm not really sure of, but that's capable. Yep. So disaster recovery. So the question is, are there any considerations for disaster recovery? That is something we are working on now. We actually have a team who is sitting down. Essentially, if you're familiar with the VMware validated designs and you kind of look at what they do for the dual region and disaster recovery, we're looking to kind of follow along that. So if you go look at what the VVDs do, that's kind of what we're looking. Right now, we don't have anything built in of dual region support or multi-region support, anything around vSphere replication or SRM included in the product, but that in the future, you should see that come in. All right, so I think that wraps us up. We're out of time, so thank you very much. It's been a great talk to you. I hope you enjoy the show. Thank you.